Section 1.2 is on linear functions. All right, a linear function is a relation in which the two variables, x and y, are raised to the first power. Okay, so that's important. That means that the variable, say, x is just like this. Okay, it's not to the second power. It's not a square root. It's not on the bottom of a fraction because that translates to x to the -1 power. All right. Plotting the ordered pair always produces a non-vertical straight line graph. When written as an equation, linear functions are generally written in one of the three formats. We're going to look at that in a second. But I really want to take a look at this table and this graph right now to show you why it's linear. One of the big reasons why something would be linear, if you're not looking at the graph, is the x and y values are changing at a constant rate. So as x goes down by 1, the y values are going up by 2. It's the same ratio, right? We could have also used this. As x went down by 2 from 3 to 1, the y's went up by 4, -1 to 3. That's the same ratio, right? +2 and -1 is the same ratio as +4 over -2. Those are the same values, right? And you could see it in the graph. We're going down 2 over 1, down 2 over 1. Or we could go down 4 over 2. When you graph that, that will look like a line. In math verbiage, x and y change together at a constant ratio. Okay, so here are those three formats we were talking about. When you first learn about linear equations, you learn about slope-intercept form, y equals mx plus b. Then you learn about point-slope form, and then you've got your general form. So let's start out just with a little refresher. Using this table of values and this graph. So my y-intercept is right here. It's where we hit the y-axis. And that y-intercept is at 0, 5. We can also see it here in the table. It's always where x is 0. So my b value in y equals mx plus b is going to be 5. All right. My slope we've already looked at. My slope was the change in y over the change in x ratio. As my y's go up by 2, my x values are going down by 1. So my slope is -2, right? 2 divided by -1 is -2. So for slope-intercept form, we could just plug those values in to m and b. Okay, so we have y equals -2x plus 5. Now, point-slope form, this time we're going to take a point, any point in the table. So let's go ahead and use, I don't know, -1, 7. So I'll use x1, y1. I will pick -1, 7. I could have picked any of those points in the table. And I'm going to plug that in for x1, y1, and m stays the same. And I get y minus 7 is equal to -2 times x minus a -1. And we normally write that as x plus 1. So there's my point-slope form, okay? Now, general form, and again, all we're doing is we're writing equations from the same pieces of information. So these equations modeled as a graph look like the exact same thing. So general form, we just pick one of these previous forms. Maybe we'll start with slope-intercept. And we want it to look like that, okay? So I basically just need to get that term that has the x in it over on the left side. So we would add 2x to both sides, right? Add 2x, add 2x. And what I'm left with is on the left side, I would have 2x plus y is equal to 5. All right. And again, if I graphed that, it would look like the exact same graph that we started with. All three of these equations that I've now developed, they're all the same line, the same table of values, just written in a different format. Now we're just going to jump right into the examples. Excuse me, that's my dog. So example 1, label each equation as linear or nonlinear function. If it's nonlinear, explain why. I'm just going to go ahead and explain to you on this video. I'm not going to write it. So y equals 6 times x minus 1. So let's simplify that. Right, we distributed. Hey, that's x to the first power. We are linear. Okay. Here, well, y equals, that x is on the bottom of a fraction. So that looks like this. X to the negative 1 power. That is non-linear. I'm actually not going to worry about if it's a function or not, okay? Ooh, the square root of x. That is not to the first power, okay? That's y equals, you may not know this yet, but a square root is the 1/2 power. So that is non-linear. Huh, y equals 3.8. Well, I could write that like this. X is to the first power. It's just being multiplied by 0. The slope of this is 0. So it is linear. And if you think about the graph of that, it's going to be a horizontal line where y is 3.8. That is a line, okay? Look at this guy. That's clearly to the second power. So that's non-linear. This one, let's see here, y equals, so x is being divided by 3. You know, that's the same as multiplying by 1/3. That x is to the first power. So that is linear. It's just got a slope of 1/3. Okay. All right, label each graph as linear or nonlinear, and we are going to determine if it's a function or not. Okay, so linear. Does this first graph look like a line to you? It is not. That is not a straight line. That is a parabola. So non-linear. But it does pass the vertical line test, right? If I draw a vertical line, I don't cross the graph at more than one spot. So that is a function. Okay, this next one, that is definitely a line. So that is linear. And it passes the vertical line test. So it is a function. Each input has only one output. Oh, that is a vertical line. So that fails the vertical line test. So it's not a function. Is it a line? Yes, it is. It is linear, right? That's x equals 3. Okay. Even though that is x to the first power, so it is linear, when you graph it, it's a vertical line. Every time x is 3, it's got all kinds of different outputs. It's got 3, 0, 3, 5, 3, negative 3. So x has multiple outputs, not a function. Okay. All right, label each table as linear or nonlinear. So how are we going to tell? Well, when you have a table of values, what you're looking for is a constant ratio of the change in y over the change in x. It's got to be constant. Okay, so as my x goes up by 3, my y is going up by 6. Let's see if that stays the same. Up 3, up 6. Looks good. 9 to 12, up 3. Oh, okay, it's got a constant rate of change. So it is linear. Okay, and no x value is listed twice, so it is a function. Okay, let's see here. Plus 1, it's going, y is going up 3. As x goes up 1, y is going up 4. Oh, that is not a constant ratio. So that is non-linear. Is any x value listed twice? Nope. So it is a function. It's just not linear. All right, these are going down 1, down 1, down 1. The y's are going up 0.5, 0.5, 0.5. Hey, constant ratio. So that means it is linear and none of the x values are repeated. So it is a function.